Recording is started. Hi everyone, welcome to the session on C language, which currently will deal with the IO file system and etc., type def etc. And this is the fifth session, and Jamid has been leading this study circle for the C language for the preparation of the PGD AI, that is postgraduate diploma in AI coursework. And this study circle started with ML, AI ML, and continues on that track to get you ready. So welcome, Jamie, for this C language session 5 for the PGD AI. Thank you very much. Go ahead.
Yeah. Thank you, Prakash, for the introduction. Hello, everyone. My name is Jamit, and today is the C language session 5, where we'll be discussing more about file and how C language handles file, some of them, and uh, how it uh, how it reads file and the mechanism to do it in a way. So let's get started. So first is so whenever we write a program, the we have to keep the variables or the data within the buffer and or on a hold in a certain part of memory, and then constantly refer it whenever we need it. But as soon as the program is terminated and the data is lost, so that is the reason we store the files in order to refer it back for our future uses in any manner, whether it's a partial or full. So storage is needed when data is needed to be accessed again for future use in part or whole. This medium through which we do it is usually called as file on disk or storage. So the way data is organized with when we run a program, a C program, is that we build a C program with the help of library functions, and these functions interact with the OS that the user is using, and it uh, it saves the information on the hard drive or disk. So whenever we manage C program with the disk space or the files on the disk. And there are certain operations to it. So there are file operations to it. So file operations are creation of a new file, opening of a new file, reading and writing, then moving to a specific location and closing of a file within the program. So let's discuss those. So this is the program, and this is a short program of opening and closing a file. So after the header files, we go to the end main, and then our main function. Then we set a file for the pointer fp and character ch. Now character ch will be saving our characters as we keep reading it. So fp equals to fopen is a command for opening the file. So you can see it takes two arguments, which are pr1c.c and r, which means we are only opening it in reading mode. And then as uh, as we have opened the file, now we will be using a while loop to read the file. So as I said that character ch will be uh, saving the inputs or the characters that are being read on the file, and fp will be pointing towards the first. As we have opened the file, fp will be pointing towards the first character of the file. So uh, so as you can see, the while loop has been made in an indefinite manner. So if we don't break it, we it will be keep on running. So how do we do it? So you can see there is an if statement within the while loop where ch equals to e or f. So EOF is end of file, which is a macro which is given, and if the ch comes around it, it breaks through the while loop, and or indefinite while loop is uh, is is terminated, and 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 after reading the end of the file, now the we have to close the file. As we have opened the file, we have to close the file. Now while closing the file, we can do it simply with a pointer rather than with the file name and read mode and stuff. So you can see that f close is used with the help of pointer. We have closed the file, return 0, and the whole execution of it is done. So we'll do a step by step of the program that we just saw. So f open for opening the file. So before we start the with reading and writing, we must open a file first. So what f open is doing three tasks for us. It searches the file in the storage, then it loads the file from the storage to a place in memory called buffer. It sets the character pointer to the first character of the buffer. So this is where the FP is used. Why use buffer? So that we can do a read and write operation in one go and transfer all the changes on the disk rather than performing read and write operations every time for every character for the file in the memory storage. So read after opening a file, we have to read from the file. So after opening a file, it is partially or fully loaded into the buffer with a pointer pointing towards the first character of the buffer. So ch equals to f get c. Fp is the command. So f get c reads the first character, then advances to point towards the next character, returning the character that is read and stored in a variable ch. And the file now being opened with will operate through file pointer fp. We have used a function in an indefinite loop to read the file, and at the end of f get c returns a macro of end of file, which helps us to break out of the loop. So after reading the file, we close the file. So f close is used with an argument fp as a pointer being passed. So it is used to close the file using the pointer fp. On closing, the buffer associated with the file is removed from the memory. And if we write in the file using f put c, the character would be written into the buffer. After closing, so the character written would be written on the file on storage, and the buffer would be eliminated. So this is another program that reads the file and counts the characters, space, tabs, and new lines in the file. So most of the program is pretty much understand self-explanatory, apart from the opening of the file. So the file as the previous program, it starts within the main function. It starts with file pointer fp, then character ch. Now as we have opened the file, we have got the while loop, and then ch for reading the file with the help of the pointer within the f get c function, and end of file equating to ch in order to break the file loop. Now, now NOC is for the spaces, and as soon as the space is counted, it is it has been incremented. Now, same for new lines, same for tabs on the left side, and all of those counters have been incremented and being saved. So after reading the whole file, the f close is passed to close the file with the help of the pointer, and printing out each and every uh, one of them for actually NOC for characters, but NOB for the blanks. Sorry for that. So after closing the file, we'll be printing each and every number of characters, number of blanks, tabs, and new lines. And if the program is successful, it gives us the exit code of 0. So as we have been reading the file, there are different types of reading modes to it. Uh, as we saw earlier, that we only opened the file with the help of reading mode, and same for this program also. We opened the file with reading mode. So uh, so our Now, whenever we use reading mode, the opening modes, you can we'll start with the explanation of R. So R searches the file. If the file is opened successfully, F open loads it into the memory and sets up a pointer which points to the first character in it. Then W searches the file. If it exists, it contains are overwritten. If the file doesn't exist, a new file is created. A searches the file. If it's opened successfully, F opens loads it into the memory and sets up a pointer that points to the last character in it. If the file doesn't exist, a new file is created. For R plus, it searches the file. If is opened successfully, F open loads it into the memory and sets up a pointer which points to the first character in it. A plus for if file is opened successfully, loads it into the memory and sets up a pointer which points to the first character in it. If the file doesn't exist, a new file is created. And W plus, if the file exists, contents are overwritten. If the file doesn't exist, a new file is created. So all the operation returns null if they are unable to open the file, or if the file is failed or doesn't exist to operate. So it returns null in case any of the workings has not been intended or done in an or done and not reacted in an intended manner. So there are different modes to it, and the way we handle a file. So there are different opening modes as well. So one is text mode, and then is binary modes. Most of the operations related to text mode and binary mode are same, but they differ in some manner. So let's start with text mode first. So text mode is a mode in which files are handled by default and the way it is intelligible to us, whereas in binary it is the ASCII values of those characters. So two places where these modes are different are handling new lines. So in text mode, a new line character is converted into the carriage return line fit combination before being written to the disk. Likewise, the carriage return line fit combination on the disk is converted back into the new line when the file is read by a C program. This does not happen when it's opened in a binary mode. The store Next is the storage of new numbers. So numbers are stored as strings in memory. So the number 1234.56 will take 7 bytes, 1 byte per character. Hence, if a large amount of numerical data is to be stored on the disk, using text mode may turn out to be inefficient. The solution to it is to open the file in binary mode and use those functions, fread and fwrite, which stores the numbers in binary format. It means each number would occupy same number of bytes on disk as it occupies on the memory. So there is another way of opening or handling different operations. So which is a low level file input output. So in low level file input output, only buffer full of bytes can do the read write operations. So programmer sets up the buffer, puts the appropriate values before writing and takes them out after writing. So in a way, buffer becomes part of the program, giving us these advantages. So actually, in a way, you can think that it everything is been manually done. So buffer is introduced within the program and takes out is terminated within the program as well. So which gives us these advantages, since these functions parallel these functions parallel the method that OS uses to write on the disk. They are more efficient than the high level file input output functions. Since there are fewer layers of routines to go through, low level input output functions operate faster than their higher level counterparts. So So when we see programs as to always open the file, compile and execute it, we should be able to do it in a command prompt. So so that is where the passing int argc and pointer argv is used. So argv is the array of pointers to the string, and, and argc is the int to the number of strings the argv is pointing at. So the first string is stored in argv for argv0, and the second string is stored in argv1, and so on. And argc contains the number of strings given in the command line. So if there are three things being passed, which is file copy pr1.c, pr2.c, the rc would contain the value of 3. So this was all the theoretical way to state the file input output of the how C program handles it. So and these are the references that are used to present this session. So thanks a lot for listening, and I'll give back to Professor.
Okay, thank you, Jamit, for the presentation. It was excellent. And let's do the demo of the same what we have for the file IO in the next session. And
Sure.
in the meantime, of course, we can also take a look at the what you call the uh, file index, which is in Unix next time. That will be how the inodes are formed and how files are organized in
Okay.
the latest, as well as on the FAT, which is the DOS and Windows, which used to extended FAT and all. So those are important from the point of view of system, and we'll cover that next time. Okay, I think
Sure.
good job. Let's close this session. We'll once again see you on Monday. Okay,
Sure.
take care. Bye.
Thanks.